Okay, for Geometry 2.2, we are still talking about hypotheses and things like that. So here are some good definitions for you. When you're looking at a statement, if it's a conditional statement, it's in an if-then form. So if something happens, blah, 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 if I do something, then something happens. So that would be a conditional statement in an if-then form. The symbol you use for it is from P to Q. So if P happens, then Q. Okay, we'll do some of those examples here in a bit and so you'll get it more. The hypothesis is the part P following the word if. So you read it as if P, then Q, or P implies that Q happened. And then the last vocab word for today is the conclusion. It's what it sounds like it is. It's the Q. It's the part that follows then. All right. And then we may or may not actually reference this diagram. If P, then Q happens. So P happens because of Q, but you will know the symbols P and Q. We'll talk more about that later. Excuse me. All right, here's your first example. What are the hypothesis and the conclusion of the conditional? So it's already in a conditional form, so there's an if and a then. What I want you guys to do is I want you to underline the hypothesis, the whole hypothesis, and then we'll also underline the conclusion and we'll separate it out. So if an angle measures 130 degrees, then the angle is obtuse. So underline the whole if statement, which is if an angle measures 130 degrees. Actually, then we'll circle the conclusion. So we'll underline the hypothesis and we'll circle the conclusion. So the hypothesis is if an angle measures 130 degrees, the conclusion is then the angle is obtuse. So I didn't actually need to underline the word if. If and then are both there, but the hypothesis is if an angle measures 130, the conclusion would be that the angle's obtuse. Okay, then it wants to know, let's see. Actually, I'm going to go ahead and teach you what the word Converse is. No, it's not a fancy tennis shoe, sneaker. So we're going to write the converse too. The converse is when you take P and Q and you flip them. So the converse, I wasn't going to do this today, but just kidding. Converse today is going to be if Q, then P. So if we took our sentence, if an angle measures 130, then the angle is obtuse, we are going to flip them. If the angle is obtuse, then it measures 130 degrees. Now, let's go back and say if these hypotheses are true. Is it true that if an angle measures 130 degrees, then the angle is obtuse? That is true. What about if I flipped it and gave you the converse? If an angle is obtuse, then does it have to measure 130 degrees? That would be false. And let's go ahead and use our words from the last lesson and provide a counter example. What's another angle that is obtuse that does not measure 130 degrees? Well, it can measure 120 degrees. So this is our counter example, 120 degrees. All right, let's look at example 2. How can you write dolphins are mammals as a conditional? And remember, a conditional statement has an if-then format. So how can you write dolphins are mammals? What about if an animal is a dolphin? Then it is a mammal. All right, and let's think about that if that is true or false. If an animal is a dolphin, then it is a mammal. A dolphin is a mammal, so this would be true. Okay, let's practice writing the converse. So we're going to switch the P and Q. So the converse statement would be if an animal is a mammal, then it is a dolphin. So, if an animal is a mammal, then it is a dolphin. That would be false. And let's give a counterexample. If an animal is a mammal, then it is a dolphin. False. Can you think of another mammal that is not a dolphin? I don't know. A kangaroo, is that a mammal? I don't even know. That might be wrong. We'll talk about that. I think it is. Okay. Problem 1. What are the hypothesis and the conclusion of the conditional below? So let's also, I didn't have you guys do this before, but if I want you guys to underline the hypothesis and circle the conclusion, let's practice doing that. So let's underline the hypothesis. If an animal is a robin, then the animal is a bird. All right, so obviously the hypothesis is here and the conclusion is here. The if comes first and then the then. And then I think we should practice writing a converse of this as well. So converse again is just if Q then P. So if the animal is a bird, then it is a robin. Okay. And once again, if it's a robin, it's a bird would be true. If it's a bird, then it has to be a robin is false. And we can give a counterexample of any type of bird you can think of. An eagle. How about that? All right. How can you write the following statement as a conditional statement? Vertical angles share a vertex. Vertical angles share a vertex. So let's first start by writing the conditional. So the conditional statements are always in if-then form. It has a hypothesis and a conclusion. So let's say if two angles are vertical. If two angles are vertical, then they share a vertex. All right, let's practice underlining the hypothesis. If two angles are vertical, and we'll circle the conclusion, then they share a vertex. Is that true or false? If two angles are vertical, then they share a vertex. That would be true. The converse is if two angles share a vertex, then they are vertical. Let's think about if that's true. If two angles share a vertex, then they are vertical. That would be false. So a counterexample would be something like this. So these are two different angles that share a vertex, but they are definitely not vertical. So here's your counterexample. All right, so let's go on to the back. We have kind of already talked about the conditional statement. So it uses an if-then form. If P, then Q. That's what that symbol reads, if P, then Q. And then the converse, I've already shown you how to do that, but basically it is where you flip-flop them. If Q, then P. So an example of a conditional is if the measure of angle A is 15, then angle A is acute. And if you flip those and do the converse, if angle A is acute, then the measure of angle A equals 15. So sometimes they are both true, sometimes they are both false, and sometimes one is true and one is false, depending on how it is worded. Now we're going to add two more things. There's the conditional statement and the converse, and then we have what happens when you inverse them, and then when you have a contrapositive. So the inverse is when you negate both. So it's still in the same order of if P then Q, but this little kind of like a tilde, this little symbol in front of it is going to represent the word not. So if not P, then not Q. Okay, so based on this example above that we gave here, we're just going to throw the word not in front of it. So if the measure of angle A does not equal 15, then angle A is not acute. So we threw a negative word in front of both, but they still went in the same order. A contrapositive is when you throw the word not in front of it, but you also switch them. So it's more like the whenever you would put a not in front of the converse becomes the contrapositive. So we're going to do this. I only gave you a couple of them because they take a lot of work, and I think basically it's just practicing your writing and knowing what the differences are between these four parts. So example 3 says, what are all four? The converse, the inverse, the contrapositive, and of the conditional. So we'll originally have the conditional statement below. What are the truth values of each? That just means is it true or false? And if the statement is false, we'll give a counterexample. So here is the conditional statement. Conditional. If a vegetable is a carrot, then it contains beta carotene. Okay, so we are going to start by writing the converse of this. So the converse is what we did on the other side. We're just going to flip-flop them. So if a vegetable contains beta carotene, I think that's how you say it, then it is a carrot. All right, let's go back and answer the true false about each one. So if a vegetable is a carrot, then it contains beta carotene. That one is true. There is that beta carotene stuff in a carrot. However, if a vegetable contains beta carotene, then is it a carrot? Must it be a carrot? That one, I'm just going to go ahead and tell you is false, but I don't know my vegetables good enough to be able to tell you a counterexample. So maybe you should go look one of those up. And while you're at it, check and see if a kangaroo is a mammal. Okay. Then we're going to write the inverse. All right, remember the inverse is the same as the conditional. We're just going to throw a negative in front of both parts. So the inverse would be if a vegetable is not a carrot. Okay, if a vegetable is not a carrot, then it does not contain beta carotene. All right, let's think about the true or false of this. If a vegetable is not a carrot, So maybe you're thinking it's a radish. Then it does not contain beta carotene. There are other vegetables that contain it, so this is going to make it false. All right, and then the last one is the contrapositive. And the contrapositive is the same as the converse, except we negate both of those two. So we put a negative word in there. So this one will be, if a vegetable does not contain beta carotene, then it is not a carrot. All right, and if a vegetable does not contain beta carotene, then it is not a carrot. So that would be true, because if it does not contain it, then we know it can't be a carrot, because carrots do contain it. All right, last problem. What are the converse, inverse, contrapositive of the following conditional statement? What are the truth values of each? If a statement is false, give a counterexample, which I did not do a very good job of last time. We'll see if we can do it this time. This is the conditional statement. If the figure is a square. If the figure is a square. I forgot to circle and underline last time. That's okay. Then the figure is a quadrilateral. All right, let's go ahead and start with the converse of that. So the converse is when you just flip them, and if Q, then P. So here we go. If the figure is a quadrilateral, then the figure is a square. All right, I forgot to do the true or false about the first conditional statement. So if the figure is a square, the figure is a quadrilateral. That would be true. All squares are quadrilaterals, four-sided shape. All right, however, if the figure is a quadrilateral, four-sided shape, does it have to be a square? This one is false, and I'm thinking of a rhombus. So that is a quadrilateral, but it is most definitely not a square. This is my counter example. All right, let's move on to the inverse. So remember, the inverse is the same as the conditional statement. We are just going to negate both P and Q. So if the figure is not a square, then it is not a quadrilateral. All right, let's think about that. If the figure is not a square, so I'm thinking of maybe a triangle or any figure that is not a square, then it is also not a quadrilateral. Well, that's not necessarily true, because let me go back to like a rectangle. If the figure is not a square, it could be a rectangle. Then it is not a quadrilateral. A rectangle is a quadrilateral. So I'm going to make my counterexample a rectangle. All right, and then the last one, this is your contrapositive. And the contrapositive is the same as the converse, it just negates. So if not Q, then not P. So this would be, if the figure is not a quadrilateral, I'm going to abbreviate it quad. If the figure is not a quadrilateral, then it is not a square. All right, let's think about that. If the figure is not a quadrilateral, okay, then it is not a square. If it's not a quadrilateral, that means it doesn't have four sides. And a square does have 4 sides, so it could not possibly be a square. So this one would be back to true.